Let's take a look at another interesting case. In this example, question says find the slope of the tangent line to the following curve. This curve doesn't pass vertical line test. It is not a function. It's defined as 2 times x plus y to power a third equals to y at the point 4 and 4. And as you can see, it's defined implicitly. You have a relation between x and y, and none of them are isolated on one side. Very good. So we're going to start by taking the derivative of this relation. To take the derivative of this relation, we need to apply different techniques that we learned in calculus. First of all, you have a quantity raised to power a third, so you're going to use the power rule. You get 2 times 1 over 3, which is 2/3, times x plus y to a third minus 1. So note that we have to subtract 1 from the exponent. That's how you end up with negative 2/3. And then applying the chain rule, the derivative of x is 1, and the derivative of y is dy over dx. It's not 1. And on the other side, again, we have the derivative of y, which is dy over dx. Very good. Now you're going to distribute 2/3 x plus y to power negative 2/3 into parentheses, and you get 2/3 x plus y to negative 2/3 times 1, which is just right here. And you're going to bring the other term, which is multiplied by dy over dx, to the right-hand side, because we're going to group these together and write dy over dx or y prime. This is our goal. So once you subtract 2/3 x plus y to negative 2/3 dy from both sides, you can see you have both dy dx terms on one side. You can factor it out, and you end up with 1 minus 2/3. If you factor out dy over dx and open the parenthesis, you're left with 1. It is not 0. Minus 2/3 x plus y to negative 2/3. And then you're going to divide everything by that term. So you get dy over dx equals to 2/3 x plus y to negative 2/3 divided by 1 minus 2/3 x plus y to negative 2/3. Now we're going to do a little bit of algebra. In our algebra, we're going to multiply both the numerator and the denominator by 3 times x plus y to 2/3. Why is that? Because x plus y to power 2/3 and x plus y to power negative 2/3, if you combine these together, negative exponent, positive exponent, they are the same, they're opposite of each other, so you get 0. Any non-zero number raised to power 0 is equal to 1. Or basically, you can cancel out x plus y to power 2/3 and x plus y to power negative 2/3. And 3 on the numerator with 3 on the denominator, they get cancelled out as well. Once you distribute 3 times x plus y to 2/3 into parentheses, you get 1 times 3x plus y to 2/3 minus 2/3 times x plus y to power negative 2/3 multiplied by x plus y to power 2/3. The same thing what we did in numerator, we're doing the same thing on the denominator. 3 and 3, they get cancelled out. X plus y to power negative 2/3 and x plus y to power 2/3, they are basically combination equal to 1. So you're left with dy over dx, the derivative equals to 2 over 3 times x plus y to 2/3 minus 2. Very good. So this is our derivative. Now that we have the derivative, we can simplify it a little bit further. You can write dy over dx equals to 8 divided by 3 times y squared minus 8. Why is that? Because 3 times x plus y to 2/3 is basically y squared divided by 4. And finally, now that we have dy over dx, either of these formulas are fine, whichever you feel comfortable using. Our goal is to find the slope of tangent line. So eventually you're going to plug in x equals to 4, y equals to 4 into either of these two formulas, and you get 1 over 5 as the slope of the tangent line. As you can see, the slope is positive, so we expect to see an increase at that point. And once you graph the tangent line, this is the slope of the tangent line, 1 over 5, and this is the tangent line itself. those of you to review the equation of tangent line, remember that algebra you learned about equation of tangent line, slope n passing through a point x1, y1 is y minus y sub 1 equals to m x minus x sub 1. So since here we have the line passing through 4 and 4, y1 and x1, both of them are equals to 4. And as you remember, the slope of the tangent line is 1/5. So we can plug them into the formula and simplify it, and you get this line as the tangent line to this relation. Again, guys, this is not a function.